So just kind of thinking about the graphs of these. So let's think about how many different ways can a conic section and a line intersect. A conic section and a line. Well, first of all, you could just have them totally not connect at all. So if I have a circle and a line, how many solutions would this one have? None, because they would not intersect anywhere. Good. Okay. Do we think it's possible to get one solution? It is possible. Yes, it'll just kind of touch it on the side. It'll be tangent to it, is what that's called. So say we have a circle, and then our line is over here, and we have that one intersection point. That would have one solution. Right? And then, obviously, if you have a circle and then a line that passes through it, that could have two solutions.
And it would be like,
Of course, it'll also be the same number, though. Yeah.
well, like a hyperbola, that has.
Really?
That's just an inverse circle.
Yeah. Okay. How many different ways can two conic sections intersect? There's actually quite a lot. Again, you could have none. So say you have a hyperbola and then a circle just chilling over here. That would have no solutions. Okay, we can definitely have one as well. So say we have a circle and then we have another circle that just touches it on the side. It's tangent to it. That would have one solution.
Wow. It's the LR. Alexa, right?
No, it's not. It's also possible to have it be two solutions. The two solutions reminds me of like the Olympic symbol. You have one solution here, one solution here. What about three? Do we think it's possible to have three solutions for two conics?
Yeah, really. You can have more than three because you can have it like infinitely as we order that way.
That's true, Danny. Good job. Three solutions. Say we have an ellipse, and then we have a parabola inside that ellipse. This one would have three solutions. 1, 2, 3.
Oh, could you have like hyperbola inside that ellipse? So I have like 4 solutions.
You think we're going to get to 4 next, Danny? Considering we've done 0, 1, 2, and 3, you think 4 will come next? I think 4 will come next. Yeah. Common sense is telling me. All right, so for 4 solutions, we'll have a hyperbola, and then some sort of either circle or ellipse in the center, getting you those 4 points. And then obviously the one last one is it's possible to have infinitely many solutions. When you graph one and it's a circle and then you graph the other one and it's the exact same circle, then that's infinitely many solutions. So we're going to run it. Today we're just focusing on conic intersecting with a linear function, a line. So to do these, we're going to use a method that we learned in Algebra 1. It's called substitution. In order to substitute, you're going to need to isolate a variable. So looking through both of these equations, which variable looks the easiest to isolate? The first y, right there. To isolate that, we would subtract the 2x, giving us... No.
Why minus?
No.
Why x not what?
Negative 2x plus 3.
Why minus?
Okay. And then we'll take what that y is equal to, and we're going to substitute it into the other equation in place of its y. In that other equation, can you tell what shape that is? It is not a circle. That's an ellipse. Good. The top one is a line. All right, so here comes our substituting. We'll have 3x squared. In place of that y, we'll have negative 2x plus 6 squared equals 12. Okay. We do need to FOIL this little bit right here. So we're going to have to do negative 2x plus 6 times another negative 2x plus 6.
4x squared minus.
That would be, yes, the first one would be 4x squared. And then we'll have negative 12x and another negative 12x, which would make negative 24x. And then last times last would be 36 equals 12. What type of equation is this? It's a quadratic equation, right? For a quadratic equation to solve it, we probably want to combine like terms and then set it equal to 0. Let's see, so we'll have 7x squared minus 24x. And then we'll subtract that 12 on the right to get plus 24. To save us all time, I'm just going to let you know, spoiler alert now, it is not factorable. So it's not factorable. What do we have to use to solve it? Quadratic formula. Where we use this for our A, this for our B, and this for our C. So we'll have x equals negative B, which would be negative of negative 24, just 24, plus or minus
Negative of
B squared minus 4 times A times C,
over A.
all over, not just A, 2A. Let's simplify inside the square root real quick.
500.
Thanks, Danny. We're trying to get through the lesson fast. Okay, and then minus 4 times 7 times 24. So 576 minus 617. All together inside of our square root. Everybody's got a calculator on their desk, so I don't know why y'all waiting for Danny to do it. It's negative 96. Okay, which means if we're trying to find the real actual points that these two cross at, are there going to be any real actual points? We don't have to do it. The solutions would be imaginary, and there's no point in writing down imaginary points they cross at, which means they don't cross. So, no solutions to the system. They wouldn't cross because you'd have a square root of a negative. They do not intersect. Hallelujah. All right, looking at the next one. Okay. What shape is that top conic? It's a circle. So we have a circle and a line. We do need to isolate a variable in order to substitution. Which variable would we like to isolate? X on the second one?
Wait, no, why?
Y on the second one?
Subtract what?
Okay. Let's see. To isolate Y, we'd have 3y equals negative 4x. And then if you divide by 3, you get y equals negative 4 over 3x. And then once you have a variable isolated, you can substitute it into the other equation in place of that variable.
Squared plus parentheses equal 3x.
I'll have x squared plus, in place of that y, we'll put negative 4/3 x squared minus 25 equals 0. How do I square a fraction?
You square the top and bottom.
Square the top and bottom. Very good. So that would give me negative 4 squared on the top would be 16. X squared would be x squared.
Square the top.
Yes, that is algebra 1. How do I get rid of that 9 denominator? Yes. I'm going to multiply everything by 9, and that'll get rid of my fraction. So we'll have 9x squared. Plus the 9 will cancel out on the next one, so we'll get 16x squared. Minus, what's 9 times 25?
245.
Equals 0. If I combine those two like terms, 25x squared minus 225 equals 0. Yeah, this one doesn't have a b term, so you could just isolate your squared term and then solve it using square roots. So I'm going to add 225 and 25x squared. Equals 225. And then we could divide both sides by 25, which gives you x squared equals 9, which means x equals
3.
or negative 3.
100% cooler.
I want to say, you know that it's in this. I don't know if that's correct.
So there's two x values, which means that there's going to be 2 points they cross at. And so far, we only know the x of those points. So we still need to find the y of the point. So we're going to find y when x equals 3. We also need to find y when x equals negative 3. Okay. Is there a great place to find y?
Yeah.
Yeah, right here. It says y equals negative 4/3 times x. So y equals negative 4/3 times the x, which would simplify to just negative 4. Very good. Well, then one of my solutions would be 3, negative 4, the x and then the y. Okay, and then we'll also find y when x is negative 3, taking that negative 3 and putting it right here. So we get y equals negative 4/3 times negative 3, which is
4.
Yes, positive 4. So that would make my second solution negative 3, positive 4. So this one has 2 points they intersect at.
Yes, sir.
And then one last one. What shape is that first one? No. It's an ellipse again. Good job. Because there's 2 squared terms that have different positive coefficients. So again, we're going to isolate a variable. Which variable should we isolate? Y on the second one? Sounds great. I think ellipses is plural. Yeah.
Ellipse is the singular.
So isolating the y. I'll add x to the other side. I'll subtract 1 on the other side. And then we can take that, what y equals, and substitute it. What's the annoying part on this one? Yeah, there's 2 places to substitute. There's a y squared and there's a y. Do we think we have to substitute it in both? Yes.
We do have times papers with the square.
The squared is order of operations. All right, so we'll have 6x squared up front. We'll have an 8, and then in place of that y, we'll have an x minus 1 that's squared. We'll have a minus 5x plus our y again, which is just an x minus 1, minus 23 equals 0. Okay, I got it substituted. I'm going to have to FOIL in this little spot here. Which will give me x squared, and then a minus 1x and another minus 1x, which is negative 2x, and then a positive 1. Minus 5x. Is this parenthesis really doing anything mathematically? No, you're welcome to drop it.
Drop it?
Yeah, as long as there's not a minus in front. If there was a minus in front, you'd have to distribute. Is this parenthesis doing anything? Yes, we need to take that 8 and distribute it, giving us 8x squared minus 16x plus 8 minus 5x plus x minus 1 minus 23 equals 0.
You must love math.
Of course, yeah. You might be the only one in here who doesn't. Okay, looking for like terms, we got a 6x squared and an 8x squared. We have some x's that would be in a group. -16, -5, +1, x. And then we have just numbers that would be in groups together. Let's use green. We got this 8. We got this -1 and this -23. All right, starting with combining the 6x squared and the 8x squared. Good job. -16 minus 5 would be -21. Plus 1 would be -20. Very good. -20x. And then we got 8 minus 1, which is 7. And then what's 7 minus 23? -16. All right. Looking at that, I can make those numbers smaller if I divide everything by what? 2. You can move seats on. Okay. This one, believe it or not, is factorable. 2 numbers that multiply to 7 times 8, which would be -56. But they got to add to -10. I do believe it's 14 and 4, yeah. 14 and 4. Which one has to be negative, though, to add to -10? The 14, right. So we're going to split our middle term. We'll group. I know, I did it the good way. GCF of the first group?
7x.
And then if I divide both by 7x, I'll have an x and a -2. GCF of the second group? 4. Which if I divide that out, I'll get x -2.
And in on x, 7x plus 1. X minus 1.
And then we'll need to write 2 little baby equations to solve those. We're trying to find the point that they intersect at, so we need to find the x value of the point right now.
Oh, yeah.
All right, one x solution is going to be, -4/7. And the other is going to be 2. Why did I divide it by 2? Because you're allowed to do that to make the number smaller. You could actually just factor it the way it is now, but the numbers are just larger and more annoying to work with. Okay, once we found the x values, we still need to find the y values of the solution. So we need to find the y when x is -4/7. And we'll need to find the y when x is 2. And we have a great place to find y. It's right here. Y is just the x value -1. Y equals, take my x value. I'll subtract 1. How can I rewrite 1 but have a denominator of 7? 7/7. So -4/7 minus 7/7 is
-13/7. Oh, wait. 11/7.
11/7, -11/7. So that makes one of our solutions -4/7, -11/7, -4, -11. So they don't always intersect at nice, pretty points. Some of them are ugly. The second one's nice, though. To find y when x is 2, well, y is just the x value -1. So that y would be... So the second solution would be 2, 1. So this one has 2 points that they cross at, just like the last one did.